This is a tour of the Impulse Response module of Audio Tools. Impulse Response is an in-app purchase in Audio Tools. Impulse Response is also available as the IR standalone app. This demo is recorded in Audio Tools, but the features are nearly identical. Purchasing the standalone IR app automatically unlocks Impulse Response in Audio Tools. This demo will be divided into two sections. The first will show how to record an impulse response, and the second section will demonstrate the features in impulse response to analyze an IR. This is section 1, which covers recording an IR in impulse response. The recording screen is accessed by tapping the sine wave icon. There are 3 ways to record an IR. The first is to record an impulse directly by exciting the space with a short, loud sound like a hand clap, starter pistol, or balloon pop. To record an IR this way, tap the impulse box and make sure that the expected maximum reverb decay time is set for 1 second longer than you expect the reverberation time to be. For small spaces, use 1 or 2 seconds, medium-sized spaces 3 or 5 seconds, and larger spaces 10 seconds. Selecting a longer decay time will result in larger saved file sizes. To record the impulse, tap the record button. Make sure the environment is as quiet as possible and then generate the impulse. Then wait for the sound to completely decay and tap stop. If you want to play back the impulse you just recorded, you can tap the play text. To see the IR you just recorded, tap done, which will bring you to the analysis screen. We are using the dual analysis view here on the iPad, which shows both the frequency analysis and also the energy time curve. When recording an impulse, there is often recorded noise before or after the actual impulse, and we want to trim that out for the most accurate analysis. To edit the recorded impulse, simply use a 2-finger drag to bring the peak of the impulse to the left of the screen, and then remove most of the noise that occurs after the impulse has decayed. To commit this trim, tap the Edit text and then tap Save File. For higher quality IRs and more accurate results, we recommend using one of our logarithmic sine sweep signals as the test signal. With the sweeps, you can play back the signal into your room under test, record the sweep, and then deconvolve this recording into a high quality IR. The sweeps can either be played back from the recording iOS device by tapping the Play Sweep File while recording switch, or played back from an external device. You must use our specialized sweep signals, which are available to download from our website. There are 3 options for sweeps: 3, 7, and 14 seconds. Longer sweeps tend to give better resolution and accuracy at the cost of recording and processing time. To record a sweep, tap the excitation signal you'd like to use, select the maximum reverb decay time, and then tap record. A synchronization pulse is first heard, followed by the actual test signal. After you are happy with the recording, tap Done and the IR will be displayed. It is very important that you do not distort your microphone while recording the test signal, otherwise you will get incorrect results. The level indicator helps you set the gain level before recording. By tapping the test tone text, a 400 Hz tone will play to set levels. Aim for the green. If there is a little yellow during the recording, that is okay as well. If you are using the internal microphone, you need to be extra careful. The internal microphone of iOS devices can distort even if the input level is not clipping. If you are getting unexpected results, turn down the measurement signal in the room a bit. It is not necessary for the measurement signal to be uncomfortably loud to get good results. You will get the highest quality results when using our iAudio Interface 2 and a high quality measurement microphone. For an excitation loudspeaker, a full range low distortion flat frequency response unit is preferred. In order to get good results from the lowest octaves, a subwoofer may be necessary. But you can still get good results with the internal microphone of an iOS device and a small loudspeaker. In the next section, we will cover impulse response analysis. This is section 2, which covers analyzing a recorded impulse response. This is the blank analysis screen you will see when you first open impulse response. You can analyze an IR in two ways, either by recording a new impulse as described in the previous section, or by recalling a previously recorded IR, which is what we will do here. Access the Save Recall screen by tapping this folder icon. I'll tap Browse and then recall the medium Hall saved IR. This is one of the 5 demo impulse response files that come with the module. A good way to set up the analysis is by having the frequency response displayed in the top section and the energy time curve on the bottom section. You can toggle between dual analysis view and single analysis view by tapping the 1 or 2 switches on the bottom left of the screen. If you have pre-recorded IRs from a third-party program or saved on your computer, you can import them to impulse response as well, so long as they are mono wave files recorded at 16-bit resolution and at a 48 kHz sampling rate. Tap the wrench icon, which will enter the setup screen, and then tap Import IR. You can see I have Dropbox sharing set up in Audio Tools, so any IRs that are in my Dropbox folder are available to be imported into impulse response and analyzed. I'll select one and then tap Import IR. If we go back to the Save Recall screen, you can see that the imported IR is available to recall. The Setup menu is accessed by tapping the wrench icon on the main IR screen. This setup menu will give you all of the customization options needed while analyzing impulse responses. In the setup menu, you have options for ETC windowing, generator output, FFT graphing options, options for load, import, or to re-download measurement signals, and finally there are the options for the 3D waterfall. These features will be demoed later in the video. The energy time curve is the magnitude of the impulse response and shows how energy is decaying in the room. Using a two-fingered gesture, you can directly measure broadband RT60 on this graph. Just put the horizontal bars on the linear decay part of the IR and make sure the lower bound is not in the noise floor. This can serve as a quick and interactive check of the reverberation time of the space you measured. The analysis can be changed by tapping on the text in the lower right-hand corner. Impulse shows the full recorded impulse response. By tapping the play button, you can listen to the recording. The Schroeder curve is the backwards integration of the IR. This is used to calculate and display the broadband reverberation time in the form of early decay time, EDT, T10, T20, and T30. The curves for each of these reverberation times are displayed as overlaid lines on the Schroeder curve. Our Schroeder implementation uses a noise compensation function to minimize the effect of the noise floor on the calculation of reverberation time. By tapping the Early Reflections option, you can zoom into just the early part of the IR. The vertical cursor will display both energy and the distance from the direct sound, which can be useful for determining how far away an early reflection is. You can change the analysis range by tapping the text on the bottom of the screen. Tapping the FFT analysis gives you the frequency response of the current impulse response. By tapping the wrench icon, you can bring up the FFT options. The FFT options settings let you adjust the graphing range of the FFT plot, as well as lock the FFT scale. If you have purchased the Reference Curves in-app upgrade for Audio Tools, options for setting up reference curves are found here as well. You can also select to sum FFTs. To sum FFTs, select this option and then load or measure 2 impulse responses. This will create a third FFT trace that is the sum of both IR1 and IR2. Multiple IR mode will be covered in more detail later in this video. The waterfall analysis is a way of looking at energy over frequency over time in the impulse response. The analysis works by taking a small slice of the impulse response, windowing it in the time domain, and then plotting the FFT of the slice. Then the window is moved in time and another slice is analyzed and plotted. This is repeated a number of times and creates a 3D graph, which helps to look at how energy present at the beginning of the impulse response decays over time. The 3D plot can be rotated by using a single finger gesture to interact with the plot. Options for the waterfall analysis can be adjusted in the setup screen in the 3D waterfall settings. Finally, a summary screen can be brought up. This includes the T30 mid, T30 at 1 kHz, C50 mid, C80 mid, EDT mid, base ratio, signal to noise average, and center time mid. Mid values are the averages for the 500 Hz and 1000 Hz octave bands. The rest of the analysis available in the impulse response module is 1 or 1/3 octave band bar charts for many popular ISO 3382 acoustical parameters. Reverberation analysis is available in the form of EDT, T20, and T30. To change from octave to 1/3 octave, tap the text on the bottom of the screen and the graph will recalculate. If there is insufficient signal-to-noise ratio to calculate the reverberation time in a band, no bar will be drawn. If the SNR is questionable, the bar will be drawn in red rather than yellow. The clarity parameters C50 and C80 can also be calculated. These are the 50 millisecond and 80 millisecond energy ratio parameters. C50 is often correlated to speech, and C80 is often correlated to music. Another energy ratio, center time, can be calculated by tapping CT. This is the balancing point of the IR where half the energy is before and half the energy is after the time displayed. D50, or definition in percent, is also calculated. Finally, the signal-to-noise ratio is displayed for each octave band by tapping the signal-to-noise text. Ideally, this would be over 60 dB for best results, but satisfactory results can be obtained with SNRs in the 50s. The impulse response module is ideal for making gated loudspeaker measurements. For a detailed demo of this measurement and analysis technique, please view the gated speaker measurement video. Using ETC windowing, you can focus on just a certain part of the IR and window out later reflections. This lets you take the frequency response of just a direct sound without the impact of later reflections, for example. This technique can also be used to window out a single reflection and see the frequency response of that. Let's recall an impulse response of a loudspeaker measured outdoors on a baffle. With the presence of the full impulse response with reflections, you can see that the unsmoothed frequency response is very jagged and does not really represent what the loudspeaker is actually doing. The reflection off the ground is coming in at about 6 milliseconds after the onset of the direct sound. For the final analysis, we will want to focus just on the first part of the IR before this first reflection. I'll use a technique known as windowing or gating to accomplish this. First, let's set the left window. I'll drag the cursor right before the IR starts. To set the windows, I'll tap the wrench icon. We offer many different types of windows, but for this demo, I will select 2-key 0.25, a half cosine window that's duration is 25% of the total window's duration. To set the left window, I'll tap the Set from Cursor text. You can see that it changed to reflect where my cursor is on the ETC graph. This represents milliseconds before the onset of the direct sound, which is normalized to 0 milliseconds. Since I know that my first reflection is at 6 milliseconds, I'll set the right window right before that, 5.9 milliseconds. For windowing reflections other than direct sound, you can change the reference time. The left and right windows are relative to this set reference time. Now I will turn on the Enable Windowing switch to perform the analysis. The window will be drawn in blue over the ETC analysis. This corresponds to the amplitude envelope of the window. Impulse response will display anything out of the window in a faded yellow color. Triple tapping on the ETC screen will automatically zoom the plot into the window for a better look. As you can see from the new FFT analysis, the response is much smoother and much closer to the actual frequency response of the speaker on my open baffle. You can recall two IRs to compare and contrast multiple measurements. With one IR loaded, I'll enter the Save Recall screen and load another IR. The second IR will show up as orange on the FFT. If I tap the IR1 text, I can switch the ETC from IR1 to IR2. On all of the bar charts, the two measurements will show up as alternating yellow and orange bars. You can look at both IRs individually, average two measurements, or do a different analysis from the two IRs. Impulse response, the IR app, and audio tools work on all current generation iOS devices and work with all audio input devices supported by the hardware.